Hi, thank you very much. I'm not Amy Prieto, that is my boss, and I am Timothy Arthur. I'm a graduate student at Colorado State University, graduating my PhD in August, so hopefully next year I'll be Dr. Timothy Arthur. But while I came here today with this opportunity that's been afforded to me is to talk to you a little bit about some of the science and technology that we've gone through in our battery company and really what we've started and what we hope to get to. So essentially what we want to do is we want to take batteries and the way we think about batteries right now and revolutionize it from the synthetic standpoint and to really rethink the way that batteries are made. And if we can do that, maybe we can achieve things like the higher power densities that cars require and the long cycle lives that cars require in order to get to a point where we can make it affordable for the everyday human being. So, in order to understand where we want to go with batteries, let's talk about where our current battery stands. So currently, and we'll recognize from some of the shapes up here, that we have our cylindrical battery, our square-shaped battery, our coin cell battery, and the more specialized flat battery right there. And what's the current theme between all four of these shapes is the fact that they're all thin-film batteries. And by using very smart engineering techniques, they've increased the power density by going through a post-synthetic step, by either twisting into a cylinder or squashing into a square. And what we hope to do is to be able to skip out the step to save some money on the production side of our battery. What the drawbacks of these certain technologies are is that they still don't have the high power densities which we require for automobiles, which is the main goal of Prieto Battery Incorporated. They also have a low cycle life due to material degradation, and because of that extra step, they do have an added cost on top of them. So, what is our main motivation in Prieto Battery Incorporated? Well, what we want to do is to be able to make something like this beauty right here, this Tesla, which some of you people might own, and is really a great engineering feat, to be able to make it affordable for an everyday person, because we still want to be able to maintain some of the standards that we want out of automobiles, to be able to accelerate fast, to be able to make it from Beaver Creek to Denver without having to stop at every single place to recharge our battery. We want that long cycle life. And at this point, Amy would make a little joke about how the cost of a battery is equivalent to 2 graduate students. I don't think that's that funny, but it just goes to show that the real problem, the infrastructure for using batteries, they're there. We have the cars, we just need better batteries in order to power them. That's really where our niche is and where we're targeting. So how do we hope to get to this point right here and reduce that $36,000 replacement cost? Oh, I'm missing a slide. Well, how we plan to do that is really attacking it from a three-dimensional architecture. And what we do is we use electrochemical techniques to grow nanowires, which I've shown you in SEM, which is a scanning electron micrograph picture at the very bottom there, of nanowires of anode material, or actual battery electrode material. And by using other electrochemical techniques, we're able to cover that anode material with a polymer electrolyte and then integrate a cathode. We are up to that point at Prieto Battery. I actually do this research yesterday, in fact. And so we're very happy with our progress up to this point. And this is just some of the examples of the results we've gotten. Because once James gives me those nanowires, I'm able to put down a conformal coating of our polymer electrolyte, and there's the 2 really hard steps of our battery. Once we put the cathode in there, we have that high surface area, and it is that high surface area that's going to give us our high current densities and our high powers, and be able to make really affordable batteries for car technology. So, just to sum it up with some of our performance goals, what we want out of Prieto Battery, theoretically, we're able to increase the power density of typical thin-film batteries by 10 to the 5th order of magnitude. And hopefully we'll be able to have a 10-fold increase in the cycle life. Now, this has been shown both scientifically and also in some of the research done in our lab. So we know that these are very possible goals that we're able to achieve. The materials chosen are pretty much a copper salt, and polymers, the part of the project I work on, well, there are in fact probably hundreds, maybe even thousands of polymers in this room right here. The great things about polymers is they're mainly carbonless species, and so they're very safe for human beings. And we're able to mass produce something that's safe, then that's just an added advantage to this three-dimensional architecture. The fabrication methods are also going to be a lot cheaper. Therefore, we can reduce the price of having to replace these batteries every 2 or 3 years, like you have to in your cell phone or your laptop right now. And we can attain a higher cycle life, and even if we have to replace our battery, it'll be on a cheaper means. So the status of our company right now is that we have a utility patent, and we have first round of funding from our angel investor, Bohemian. Thank you very much. You've really helped us progress to a point where we're able to make prototypes now, and we're very excited about the future because we have a whole bunch of new lab equipment or new toys that I get to play with every day. Downside is Amy's making me work very hard. So thank you very much for your time, and I'd love to answer any of your future questions. Thank you.